It is 5.8 billion light-years away. It weighs 100 billion times more than our sun, and according to the laws of physics we have spent 400 years writing, it should not be there. Not in that form. Not at that age. Not with that mass. This is the story of Phoenix A, the largest single object we have ever claimed to find, and the one we are least sure is real. To understand what we are about to look at, we need to calibrate our intuition, because numbers at this scale stop meaning anything. The supermassive black hole at the center of our galaxy is called Sagittarius A star. It weighs 4 million times the mass of the sun. That is already an object our minds cannot hold. Until recently, the heaviest black hole we had confidently measured was called TON 618. 66 billion solar masses, a number so absurd it sat alone at the top of the list for decades. Phoenix A does not sit near TON 618. Phoenix A sits above it, 100 billion solar masses. Let's try a comparison that might help. Take every star in the Milky Way, 200 billion of them. Add every planet, every asteroid, every dust grain, every cloud of hydrogen drifting between the stars. Phoenix A alone weighs roughly what all of that weighs together. One single point in space dressing itself with the mass of an entire galaxy. The Phoenix cluster is 5.8 billion light-years from Earth. That is a sentence we say easily, and the human mind immediately forgets what it means. So let's travel there. At the speed of light, you pass the moon in 1 1/3 seconds. You are at Mars in 12 minutes. You reach Pluto in 5 hours. If you keep going, you arrive at the nearest star, Proxima Centauri, in 4 years. You cross the entire width of the Milky Way in 100,000 years. But we are not going to the next galaxy. We are going to the Phoenix cluster, 5,800 million years, at the speed of light. While that light traveled, Earth did not yet have complex life. The continents were different. The sun was younger. By the time the photons leaving Phoenix A reach our telescope, our oceans will have evaporated and the sun will have swallowed its inner planets. The light we are looking at right now is a ghost of something that happened before we were a thought. And at the end of that journey, something is waiting. In 2010, a telescope buried at the South Pole was scanning a region of the southern sky. It was not hunting for record-breaking objects. It was mapping the cosmic microwave background, the faint heat left over from the birth of the universe. The project was called the South Pole Telescope Survey. It was methodical, bureaucratic, routine, and in one corner of the map, something glowed wrong. One galaxy cluster stood out from the thousands catalogued. It shone in X-rays with a brightness that did not fit anything in the data, 10 times brighter than it should have been. The astronomers named it the Phoenix Cluster because what they were seeing looked like a cluster rising back from the dead. Most galaxy clusters in the universe are old now. Their galaxies have run out of fresh gas. The star formation in them is dying. They have become quiet graveyards of light. The Phoenix cluster was doing the opposite. It was forming nearly 1,000 new stars per year. For comparison, our entire Milky Way forms about 1 new star a year. Something at the center of that cluster was not behaving like a black hole should behave, so they pointed everything they had at it, and they found something they could not easily explain. Numbers are abstract. Geography is not. So let us do an uncomfortable thing. Take Phoenix A and place it where our sun is. The event horizon, the black border from which even light cannot escape, would swallow Mercury in a fraction of a second. Venus would vanish next. Earth would follow, not because it was pulled in, but because it was already inside. We would never feel the fall. We would simply stop existing as an edge. Mars, Jupiter, Saturn, Neptune, Pluto, all of them would sit inside the black disk, every probe we have ever launched. Voyager 1, traveling outward for nearly 5 decades, would still be trapped deep within Phoenix A's shadow. In fact, if you started at the edge of Phoenix A's event horizon and traveled inward at the speed of light, you would reach the center somewhere around the 71st day. Not seconds, not minutes. Days of travel at the speed of light inside a single object. The diameter of Phoenix A is roughly 590 billion kilometers, 100 times the distance between the Sun and Pluto. This is not a star. It is not a galaxy. It is not really, in any normal sense, an object. It is a region of space where the universe has stopped obeying its own rules. Here is where the story stops being about size and starts being about time. The universe is 13,800,000,000 years old. We know this to extraordinary precision. It is one of the most carefully measured numbers in science. Black holes grow by eating. They pull matter in, the matter heats up as it falls, and eventually it crosses the event horizon and adds to the mass. That is the mechanism. It has a physical speed limit. As matter falls in, it glows. That glow pushes other matter away. At a certain brightness, the outward push from the glow equals the inward pull of gravity, and the feeding stops. That limit has a name. It is called the Eddington limit, after the British astronomer who calculated it in the 1920s. The Eddington limit is not a suggestion. It is written into the equations of how matter and light interact. Now, apply it to Phoenix A. If Phoenix A started at the very beginning of the universe, as a seed black hole 1,000,000 times the mass of the Sun, already an absurdly generous starting point, and if it fed at the maximum possible rate, continuously, without ever stopping, for 13 billion years straight, it would weigh about 10 billion solar masses today. Phoenix A weighs 100 billion. Phoenix A is 10 times heavier than the most generous physics we can write down will allow. It did not break the cosmic speed limit by a little. It shattered it. And there are only 3 possible explanations. Each one rewrites some part of what we thought we knew. The first possibility is direct collapse. In the earliest moments of the universe, before any star had formed, there were enormous clouds of primordial gas. Normally, those clouds would fragment into many smaller clumps, each one collapsing into a star. But under very specific conditions, radiation from nearby young galaxies suppressing fragmentation, a single cloud could have collapsed as one unbroken object. No fragmentation, no intermediate stellar stage. Just 1,000,000 solar masses, becoming a black hole instantly. If Phoenix A began as a direct collapse black hole, it had a head start. It skipped the slow childhood. But even so, the math barely works. And we have never directly observed a direct collapse black hole forming. It is a theory with no photograph. The second possibility is super Eddington feeding. What if the Eddington limit is not absolute? Recent observations suggest that some young black holes may, under turbulent conditions, briefly exceed it. If Phoenix A found a way to feed above the limit, not for a moment but for billions of years, then its mass starts to make sense. This possibility is, in some ways, the most unsettling. It does not break a single rule. It erodes a principle. It means the Eddington limit is more of a guideline than a wall. The third possibility is that we are wrong about what Phoenix A is. This is the possibility nobody wants to talk about, but it is the one we must address. We have never seen Phoenix A directly. No photograph, no silhouette. No event horizon image like the one we have of Sagittarius A star or M87. What we have is this. The Chandra X-ray Observatory detected enormous voids in the gas around the center of the Phoenix cluster. Those voids are the kind of cavities that powerful jets carve out when they blast from a central black hole. By measuring the size of the cavities and by measuring the velocity of gas near the core, astronomers calculated a mass. That calculation gave a number around 100 billion solar masses. But there are people who look at the same data and ask a harder question. What if there is not a single central black hole of 100 billion solar masses? What if there are several central black holes, a group of merging supermassive black holes near the core, and we are adding up their mass into a single imagined object? This is not a fringe idea. It is a working hypothesis in parts of the field. The measurements we have simply cannot distinguish from this distance between one monster and several very large companions about to merge. If Phoenix A is a single black hole of 100 billion solar masses, it is the most extreme object we have ever found, and it forces us to rewrite the timeline of the early universe. If Phoenix A is actually a cluster of merging supermassive black holes dressed up as one number, it is still extraordinary, but the universe stops being impossible. We do not know which of those two universes we live in. The people working on this problem today are waiting for the next generation of X-ray telescopes to separate the signal. Until then, Phoenix A exists in a kind of quantum state, either the largest object in the observable universe or a cosmic illusion produced by our own distance and our own instruments. There's one more thing about Phoenix A that almost never gets mentioned in the short versions of this story, and it is the thing that makes everything stranger. Supermassive black holes are supposed to kill their neighborhoods. They heat up the gas around them with their radiation and their jets. That hot gas cannot cool. Cold gas is what stars need to form. So cold gas is prevented from ever reaching the density where new stars can ignite. That is the model. It works. It explains why most mature galaxy clusters stop forming stars. The central black hole sterilizes the environment. Phoenix A does not do this. At the very center of the Phoenix cluster, the gas is cooling. Cold rivers of it are flowing toward the core, and every year, 1,000 new stars are being born inside the gravitational shadow of the largest black hole ever claimed. It is as if we found a wildfire that stopped halfway through a forest, turned around, and planted trees. Either Phoenix A is fundamentally weaker than black holes of its supposed size should be, or Phoenix A is not quite what we think it is. Either way, it is telling us something. We do not yet know what. Every black hole eventually dies through a slow process called Hawking radiation. Even the most massive black holes evaporate one particle at a time. They return themselves to the universe. For a black hole the size of a star, this takes longer than the current age of the universe. For Sagittarius A star, the supermassive at the center of our Milky Way, it would take 10 to the 87 years. For Phoenix A, if it truly exists at the mass we have calculated, the death takes 10 to the 100 years. Google years, a number so large that by the time Phoenix A finishes dying, the last stars in the universe will have long since faded. The last atoms will have drifted apart, the last protons will have decayed, and the cosmos will have become a quiet, dark, empty thing. In that final silence, Phoenix A will still be there, slowly evaporating, alone. The last object standing in a universe that has forgotten itself. That is, assuming Phoenix A is what we think it is, assuming we measured it correctly, assuming the number we see is a single object and not our imagination projecting a monster onto something subtler. The universe, at this scale, does not answer our questions. It responds with more questions. And the only honest thing we can say about Phoenix A right now is this. It is either the most extreme object that has ever existed, or it is a mirror, and we cannot yet tell which. One day, we will. A new generation of telescopes, a new method of measurement will finally separate the signal from the noise. And we will either confirm that Phoenix A is real in the way we first described it, or we will quietly edit the record. Either outcome will be historic. Either outcome will teach us something about the limits of what we can know. For now, 5,800,000,000 light-years away, something is there. It is ancient. It is immense. It is almost certainly doing things our physics does not yet understand. And tonight, its light continues, as it has for the entire history of Earth, to arrive quietly on the mirrors of our telescopes, asking us to keep looking.